Thank you for joining us for another episode of Try the Chicken. We're learning how to use Flutter and Flame games. Currently, Charlie is trying to eat these pineapples, and he has 4 directions of movement. Today we're going to get these bounds working so that if he encounters an odd platform, he has to go the other direction. So these platforms here are they're obstacles in this world that we created with tile D. And we're using the flame collision system. I had to make a number of changes to the collision detection system to simplify it for the tutorial. So it's only detecting collision in one of 4 directions, so it's playable and it's a little bit easier to understand. There's a GitHub repository, which is public, and you can also get the individual branches for some of the tutorials. Generally, the more complex the game gets, the more difficult it is to follow the code. So you could take a starting point and look at the code when it's at a simpler stage. I'm using this playlist here, which is public, to record where the most recent code is and the Flame. So Flame was just updated to version 1.2. I think it was updated within the last week. So now it works with Flutter 3.0.2, which is the most recent version as of today, which is in the middle of June. And I also upgraded Flame Tile to version 1.5, which I'll just record it right now. And you can also get the same assets. Here from itch.io, which are free. So the starting point for this tutorial is that Charlie can eat the pineapple, and the pineapple, which is a sprite component, will disappear. However, he's going straight through these collisions, or these obstacles, which are supposed to be a platform which we made in tiled, the map editor. So what we want to do is block it out so he can't run right through these platforms. Let's do that right now. The way I would have the code organized, there's under lib, there's actors, and there's the world. I'm considering the objects that are, they don't disappear from the screen, the world, and the actors, including the fruit. So the pineapple is an actor because the pineapple has a role in our story here where if you eat the pineapple disappears. We're going to be focusing on Charlie, and I actually have the movement for Charlie within the Charlie class, which is a sprite animation component here. And I did mention that I completely changed how we're doing the move left, move right to simplify it. Instead of having it be able to change in kind of infinite number of directions here, I'm going to simplify it to 4 directions. So this section here, I'm going to change it to GameRef.joystick. So joystick it's a class from the Flame game system, and that we instantiated it as joystick. So this joystick direction is from the joystick class, right? So if I mouse over it, it's an enum, but it's part of the Flame components. I didn't make this one up here. It's part of the Flame components input joystick component. And this joystick is also, I instantiated it here. So in main, on the, this joystick is part of the joystick component as well. I just called it joystick right there. Okay, so let's change all of this so it's just one of these 4 directions. By limiting the number of directions the chicken can go in, it'll make our collision, our response to the collision a little bit easier. So we want this guy to back out if he hits something to the right. Also, to make it easier to see, so right now I have it horizontal. I'm just going to make it left and right. So I'm going to break it out. So this one where the chicken is moving left. And we'll make this one, the chicken is moving right. And we're going to delete this part, which is the portion for left or right. And we'll do the same thing here. So this vector x, there's only an x coordinate now. This is kind of left over from when we just had this one position add statement. But to simplify it, so we're in this Charlie the chicken class. And so Charlie the chicken, that x refers to Charlie the chicken. We can now simply change it by the x velocity or x vector. We'll do the same thing here. This chicken x vector x is it's a double. So we're pulling it from the joystick. Whenever we move the joystick around, it should move. There should be no difference now, and the chicken is still able to move in all four directions here. Okay, let's continue it with the vertical movement. And this is primarily to make it easier to understand how we're reacting to the collision when it hits a non-moving obstacle as part of the world. It's moving up. Let's just copy it first. Chicken is moving down, and we will split it out so it's easier to understand. And there's a chicken y vector too. This chicken vector y is pulled over from the joystick. So the joystick is just giving us this x and y vector for movement on the screen. It's quite nice. Okay, let's see what's happening with Charlie now. Can he still move? Oh, Charlie can still move. Okay, we're going to go into the on-collision method here of the sprite animation component. Just to recap, this Charlie class is a sprite animation component, which is part of the Flame game system. Also part of the Flame game system is this collision callbacks. We're using a mixin. So the mixin is the piece of code after the word with. So it puts a bunch of methods in here that we can now access. And this is just the template. So we need to fill it in as to what happens when Charlie is colliding. The first thing that we want to do is make sure that he's actually colliding with an obstacle, and because we're doing something else when it's a pineapple or a piece of fruit. So if the other is obstacle, we need to import it from the world. So if he's hitting an obstacle is one of the pieces of brick or pieces of dirt that we have. And then we're going to check to see if he's already collided. So if he's not collided, and let's see. Okay, let's create it right here. So this, since I'm up here, there's also this joystick direction. We're going to record the collided direction. Initially, we'll just set it to idle because we're not. There's no collision initially, so I'm just using this joystick direction dot idle for the collided direction. Because I'm only checking for left, right, up, or down. So this collided direction here, dot idle, is kind of a safe, it means that it can move. Okay, let's go back down to the collision section. So we'll set the, so if it's not collided, then we will make the collided true. And we'll also set the collision direction to the current joystick. So we have the joystick in the main game, so we can access that with game ref, and then we can have a direction here. Okay, it's looking good. But we need to reset everything when the collision's over. Override void on collision end, and this requires a position component, which we'll call other. And let's just do that super dot on collision end other. Okay. So I'm using the joystick direction of idle as kind of a safe. It's basically it's free to move if the joystick direction is idle, because it'll never be idle when it's moving. So I'm just using it for the collision to help with the collision detection. I'll set with the collided to be false. Okay. Okay, let's put some checks in here. So he is moving left, and there's nothing really stopping him except the end of the world. But we want him to stop if he hits a brick or one of these collision objects that we have set up. So we'll let him move if, so a couple of different conditions. If there's no collision, so if he hasn't collided with anything, Charlie is free to move. Or if the collision direction equals, so the only time that the collided will be true is if he collided with something, right? So we're just going to let him back out at this point. So if the collided direction is joystick direction dot right, then we will let Charlie move. Okay, does it work? So at this point, hopefully Charlie will stop when he goes to the right. And he went right through it. Okay. Maybe I'll set up a couple more of these just to see. I think it switched direction, which is why he went right through it. So if not collided or collided direction equals joystick direction dot left, Then we'll let him move to the, let's give it a go. Can he move? Appears to be, yep. Okay, so let's put him down here. I didn't paint the bounding box super accurate, which is why part of his beak is in there, but it serves our purpose. Okay, so let's get it working for the up and down now. Okay, so Charlie is free to move up if he's not collided, so let's set that up first. You can make this code more compact, right? But it will be a little bit more difficult perhaps to read for each one. That's why I'm repeating it here. Collided direction equals joystick direction down. Oh, whoa. And this one is the same thing. So he's free to move if he's not collided with anything, or if the collided direction is up, right? So that he hit something on his head, so he can go back down. Joystick direction dot up. Then he's free to move. Okay. See how Charlie's looking right now. Okay. Left and right. Let's try to get down. Okay, he's getting the pineapple. Can he fit through here? Oh, he fits. Okay. So we'll try. He's okay. Expected behavior. Can he go up? He hits his head. He can go back down. Hits his head. Hits the ground. Okay, it's working as expected. There might be a few glitches if I play around with it, but haven't found anything yet. So we can probably fine-tune the collision if he gets stuck, but nothing's stuck yet. And oh, I'm gonna get this last pineapple. Okay, I think in the next video I'll try to put some type of timer or score and Flutter overlay system. Maybe he has to get all the pineapple within a certain time frame, or else other chickens will eat his food. Okay, it's pretty playable, so you could change this map obviously. As part of preparation for this project, so I created a more simplified system here where there's buttons at the top using a Flutter overlay system. So you could strip it down using this get a repository here to just the bare bones of it, or increase it to different types of map here to test out the collision detection and make sure it can move in all 4 directions. So that green square it's a stripped down version of Charlie the Chicken. So this is the map that we are using for Charlie the Chicken, but also added some additional obstacles here to make sure that the collision was working and it's free to move in the 4 things that we're checking, the 4 directions that we're checking right now. So this stripped down version of the Flame joystick 4 direction tutorial to test out different maps there's only one branch on this one, but if you click on the commits, there's 4 commits. So you could look at the individual commit here and go down to the main core of the code so that it's not that long, right? When you want to start off with something small if you're running into a problem or you're having some confusion. So you could get the, or look at the commit from one of the earlier versions of this. Okay, so go here, and then there's these commits, and you could take a point in time and see what was changed. Okay, have a great day. I'm going to continue on with the video. I'll add a Flutter overlay system to try the chicken. If you're interested in something, just leave a comment and I'll try to take that into consideration as we're building future videos. Probably after the Flutter overlay system, I will probably move on to a different type of tutorial unless there's interest in Charlie. Have a great day.